So I'll start with the refraction through the curved surface, because in order to do the lens formula, we need to do this refraction through the curved surface, right? So what is a curved surface? I've drawn the diagram here for you, right? So the ray
Yes.
of light which is passing from one, see, what is refraction? You all know. What is refraction? See, whenever there is a medium, now in this medium, this is the denser medium, this is the rarer medium. What happens to the ray of the light? It comes from one medium, goes and strikes here, and then if it is going to the denser medium, it will go towards the normal. This angle between the normal and the incident ray, it is called as the angle of incidence. This is called as the angle of refraction. Okay.
Yes.
Fine. Okay, now we are going to do a special case in which one side of the surface is a curved surface, right? Now, what is the curved surface out here? You can see that it can be a convex surface or it can be a concave surface. I'm going to draw this. I have got this diagram for you, but I will not be using this diagram. I'll be drawing this diagram for you so that you can understand it well. Now, I have got a convex surface. This is the convex surface, right? Now, the light ray, there is a principal axis, right? Principal axis means whatever is the surface, the middle of the surface to the center of curvature. See, suppose if you want to complete the sphere, there will be a center. The center is called a C. Okay. Now, the line joining the middle of the portion of the convex portion, this is O, or you can say call it as A. Now, the point, the joining these two A and C, there is a line that this line is called as what? This line is called as the
Principal axis.
Principal axis. Okay, I'm going to keep this object here at in front of this convex surface. And what is so special about it is, like, on the principal axis, on one side, if you see, there is a medium, that is mu1, which is having the refractive index of u1, and then on the other side, if you see, this is all a denser medium, a transparent medium with a refractive index of say mu2, right? Okay, now we are going to make some assumptions to do this derivation. So what are the assumptions which we are going to do in this derivation? Is first is we are going to keep the object as it is a point size wise object. It is kept on the principal axis. And second is the angle which is the rays making with the principal axis, or the angle of incidence, angle of refractions, is very, very small. And the aperture, see this part, right? I'll just put it this way. I'm going to highlight it. This, be carefully seeing it. So this particular part is called as the aperture, and this surface has to be very, very small. These are the main assumptions what we are going to do in this derivations, right? Now I'm going to keep this point size object here on the principal axis. Right. How do I draw the normal? In order to draw the normal, now what we have to do is, if it is a curved surface, any curved surface, you have to take the center of curvature, and from the center of curvature, you draw a line, and this will be called as the normal. Now, where should this line, the ray from the object should strike? It should be a straight single ray. I'm not considering all the rays. I'm considering one single ray. There will be infinite number of the rays which will be coming out of this point, but I'm going to consider only one ray which is going and hitting at this point, say A. Clear?
Yes.
Okay, now what will happen is, this is the normal. So this angle that is the angle of incidence, is the angle between the incident ray and the normal. I call this as angle I. Now this ray, because it is entering the denser medium, so what should happen is it should go towards the normal, and this is called as the angle of refraction. Is this clear?
Yes, ma'am, clear.
Now there is another ray which is coming out from O itself, but this time it is traveling towards the pole of the mirror, and it goes and goes and goes, and again meets this refracted ray, and both of them converge and form an image at I. Clear?
Okay.
Right? Okay. Now,
once again, can you explain, ma'am, like how do they converge at I?
Which rays?
The rays, the refracted.
See, actually, what is happening is, this is a rarer medium. Now, mu2 is greater than mu1. That means the ray is entering from a denser medium to rarer medium. So what should happen? What should happen? It should bend towards the normal. No?
Towards the normal.
Yeah, so it is going this way. It is going and hitting the normal out here. And from here, it should go towards the normal. So where is the direction? This is the direction. And this angle is the angle of refraction. This angle is called as the angle of incidence. Clear? Okay,
yes.
Where is the image form? See, if there is a ray which is coming from the object and is traveling normally, say what is happening is, it is going towards inside the surface along the radius. Along the radius. Radius is the normal. Right? So there is no bending. See, if there is a denser medium and there is a rarer medium, and if there is a ray which is entering perpendicular to the medium, there is no refraction taking place. It will go straight. Right? This is the rule. We have learned it in class 10th, right? Now here what is happening is, this ray is going straight, and both the rays, this is the refracted ray and this refracted ray, they will together meet at point I. Right? Clear?
Yes, got it.
Now these two rays are forming this image, and this is what the figure, I got it, and I got it here also. You can see that this image is here. Right?
Yes.
So did you get Are you able to understand what is happening here? Okay, now
Yes,
I'm
ma'am.
going to do the derivation. So do the derivations. I'll be doing all the kachadas here in this diagram, and then I'll be using the cleaner diagram for derivations.
Okay.
So I am going to do some constructions out here. The first is, in all the books together, the angle between the angle incident ray and the principal axis. This is the principal axis, right? And this is the incident ray. This angle is taken as alpha.
Huh.
The angle between the refracted ray and the
Refracted ray and the principal axis.
principal axis, it is to be taken as beta. And
Beta.
the normal and the principal axis, I'm going to take this as
Gamma.
gamma. Now I am going to add some colors to it more. I'm going to draw perpendicular. This is a construction from A to say M. I am going to draw a normal, right?
Okay.
Fine. Now, is this
Yes.
diagram very clear?
It's clear, ma'am.
Clear? Okay. Now, what
Yes.
I'm going to do is I'm going to do the same thing for the explanation purpose. I'm going to consider this diagram number 1, which is very clearly drawn in form of the picture. Is this clear?
Yes, ma'am. This is
The
clear.
same diagram, I've drawn it here. Now, this is the incident ray, which is emerging from the object. Okay. Now, from the object, it has come here and it has gone and hit the surface, which is concave in nature. This is the denser medium. I'm marking it in pink, dark pink. And
Okay.
here, the one which is uncolored, it is having a refractive index of N1. I call this as mu1. And the denser medium, it is having the refractive index of
Mu.
mu2. And mu2 is greater than, that is
Mu.
okay. Now the angle between the normal and the incident ray is taken to be I. The angle to be taken between the refracted ray and the normal, that is the angle of refraction. I said the angle between the incident ray and the principal axis is to be taken as alpha. Can you see this alpha here?
Yes, ma'am.
And the angle between the refracted ray and the image, it is to be taken as beta. The angle between the normal and
And the principal
principal
axis.
axis, it is to be taken as gamma. Yes.
Yes, ma'am.
Okay, now this is a special case in which the diffraction is happening through the spherical surface. The surface here is convex and the object is in the denser medium.
Rarer.
The object is in the rarer medium. Now, there are certain conditions which I'll be making again more. And what is that? That is that I'm going to take the sine theta to be very small. Theta, if very
Small.
So what I can do, sine theta can be taken as theta, tan theta can be taken as theta, right? You know this or not?
Yes, ma'am.
Theta should be taken as in radians. It should not be taken in degrees. It should be taken in radians.
Radians.
ठीक है? अच्छा, अब
Yes.
इसके बाद exterior angle theorem, if you remember. Suppose if I have got a triangle, the name of the triangle is A, B, and C. Now, if I extend this line, that is BC, now, and if I call these two angles as angle 1 and angle 2, what is the measure of this angle? This angle is equal to angle 1 plus 2. Are you aware of this? Remember?
Yes, ma'am. Yes, ma'am.
भूल गया कि याद है?
Remember, ma'am. Remember.
No, suppose this P, Q, and R. Now, if you want to find out this angle, what is this angle? Suppose
Angle Q plus, angle PQR plus angle PRQ.
I have written it as X and Y. So you just have to write it as what?
X plus.
Done?
Yes, ma'am.
I'm going to use this concept out here, right? Okay. Now, this derivation is done already in the school.
Yes, ma'am. Done.
So have you understood it or I have to explain this?
Once can you explain, ma'am?
Okay. But you have to write the test.
Okay, ma'am.
होमवर्क करना है और मेरे को टेस्ट देना है. टेस्ट के लिए मम्मी या कोई भी रहेंगे. So they will be sitting with you. I'll give you the derivations and that is 15 minutes flat. You have to send me the PDF. No books in front of you, nothing. You just have to write the derivations and send it me across. Only then I'll explain. Done? Okay. When can you give the test? Tomorrow evening.
Tomorrow evening.
Yeah, tomorrow evening.
So, I have my maths class. After chemistry, I have my maths.
Okay. Day after tomorrow, should have the test then.
Yes, ma'am. Thursday.
Then only then it will be possible that we are doing it fine. Otherwise, what will happen? No test. That means nothing is going to happen. Right? Okay. Now listen to this very carefully. Now I am going to use the Snell's law. What is Snell's law, beta?
And the ratio of the angle of sine, the ratio of the sine of the angle I and sine of angle R is equal to a constant.
Okay. That is what we have learned it in class 10th. But the original law is Suppose you have got, I'll go up again. Now, suppose if I have got two mediums and I call this refractive index of the first medium as mu1 and the refractive index of the medium as mu2, I call this angle as I1, I call this angle as I2, then in that case, the original Snell's law is the original Snell's law is mu1 sine I1 is equal to mu2
Sine
sine I2. This is the original Snell's law. What is this mu1 and mu2? mu1 and mu2 is the absolute refractive index of these two mediums. Hope you know the difference between the absolute refractive index and the relative refractive index. Absolute refractive index means the first medium should be always the vacuum or air.
Okay.
And the second medium should have been the medium. But if it is an absolute refractive index, relative refractive index, the medium one can be something else and the second medium can be any transparent medium. That is the basic difference between the both. Okay. Now let's go and do the Snell's law for this. We will have what is the first medium? Refractive index is mu1. So we should write it as mu1 sine I is equal to mu2
sine I.
Mark this as equation 1. Now, what about the angles? Angles are small. So what should I write? Mu1 into I should be equal to mu2 into 1. Instead of sine I, what did I write? I, and mu2, I, R ki jagah I have written as I. Right? Okay. Can I write this? Angles are small, so sine theta will become theta and tan theta is also equal to theta. So what should I write? Mu1, I can write this as tan I is equal to mu2 tan I, right? Clear? Now look at the diagram. Now looking at the diagram, I want the value of I. Now in which triangle will I get I? You see the yellow triangle? In this yellow triangle, that is the triangle N, O, and C. What can you write for angle I?
Angle alpha plus gamma.
You can apply the exterior angle theorem here. Angle I is equal to
alpha plus gamma.
Alpha plus gamma. Now, if I look at the triangle, which is now, just let me put this as a light pink triangle, if you can see this. Now look at this particular angle. Now in this triangle, what do you see? You see that gamma is equal to angle R plus angle beta. Gamma is equal to angle R plus beta. So iska matlab angle R is equal to gamma minus beta. Is this clear?
Haan, ma'am. Clear.
So what should I write here, bacha? What should I write here? Instead of angle I should put it as alpha plus gamma. And mu2, angle R के बदले में क्या लिखेंगे? Gamma minus
beta.
Done.
Yes.
Then what should I write here? For tan alpha for alpha. And tan gamma for gamma. है ना? And for tan beta, I will write tan alpha. I'll write it as beta. So put the values here. Mu1 is equal to tan alpha plus tan gamma, that is equal to mu2 into tan gamma minus, that is tan beta. Okay.
Yes.
Now, why did I not put the formula? Because here you will get confused. Alpha plus gamma. You will write, ma'am, trigonometry ka formula hai tan alpha plus tan gamma 1 minus tan alpha tan gamma. This is for the larger angles. But I'm not going to take this formula. For smaller angles, I will not take this formula. I will simply put it as tan alpha plus tan gamma here and here tan alpha gamma minus tan beta. Is this clear?
Yes, ma'am. Clear.
Did you understand the difference? If the angles are large, I have to apply the trigonometry ka formula. But if the angles are so small, I'm not going to apply that particular formula. Will you remember this? Good girl, no?
Yes. Yes, ma'am.
ठीक है, तो अब क्या करना? You have to now find out what is tan alpha. Now in this yellow triangle में देखो tan alpha दिख रहा है तुमको? Tan alpha क्या होगा?
NP by OP.
Yes, NP by, that is
OP.
Actually beta, this is M and this is point P. ठीक है?
Okay.
So actually this should be equal to, I should write it as MP plus tan gamma की बात करें तो that is also equal to NM plus, this is also NM, and in this case it is equal to M says
PC.
all the distances will be measured from the pole, not from anywhere else. Please remember, it's always measured from the
Pole.
Okay, now what is this one? This is mu2. Tan gamma, again, I know that is equal to Nm by
M by MP.
MC minus tan beta की बात करें तो I should go here to find out tan beta. Tan beta is equal to Nm and that is equal
By
to Mi. M I.
I.
This distance, right? I should take this full, na? This is the base. देखो base देखो, हाँ? Base ये देखो ये वाला. दिखा ना? Okay, I'm wrapping it again. Now I have to find out this P lies on M. Why?
M.
Why? The aperture is small. छोटा सा मैंने लिया ना, मैंने बोला क्या था, ये concave surface is very small, so the aperture is very small, so P should always almost lie on M. So what should I do here? I should write this as mu1 and take this NM as common. 1 upon MP की जगह लिख दो OP और 1 upon PC, that is equal to mu2 into NM को common ले लिया, 1 upon OC minus 1 upon OI. Now look at this as very carefully. What is the value of this OP or PO? PO. What is PO? ध्यान से देखो.
U.
U, but minus U. When this NM and NM cancels. Now mu1 की जगह रहेगा 1 upon minus U. Why did I write it as minus U?
Because it's opposite to the incident.
Yes, good. Now what about 1 upon PC? Now if you want to say from P to C, what is the value? It is plus R or minus R? See, you can see that it is R.
It is plus R.
Plus R. Why it is plus R? Because it is in the same direction as that of the incident ray, right? Mu2 1 upon OC is 1 upon R. Minus OI is that is equal to B. B is also plus. Now let me solve this. What will I get? I will get, moment please, moment, a minute. Now I can see that it is equal to mu1 into minus of U plus mu1 divided by R. It is equal to mu2 divided by R minus mu2 divided by V. I'll do this one thing. I'll bring this to the side and this to the other side. What will I get? I'll get this minus था तो यहाँ जाके plus हो जाएगा mu2 divided by R minus mu1 divided, एक minute. What did I do? Just 1 second. It is mu2 divided by V minus mu1 divided by U, that is equal to mu2 by R minus mu1 by R. Now I'll get the final results. The final result is mu2 divided by V minus mu1 divided by U, that is equal to mu2 minus mu1 but divided by R. Now when can I use this result? This result is used when the object is in the denser medium. Now put one thing. यहाँ पर दोनों जगह मेरे पास क्या था, यहाँ पर mu2 था, mu2 by V था, mu1 by U है, यहाँ पर mu2 minus mu1 है ना? हो गया? यहाँ पर ध्यान से देखना, मेरा ऑब्जेक्ट कहाँ था बच्चा? My object was in the rarer medium. So the formula is mu2 by V minus mu1 by U, that is equal to mu2 minus mu1 divided by R. Got this? Right? This is a very important formula. This is a very important formula. Clear?
Yes, ma'am.
Right. Now, when did I get this result? This is when the object is in the
rarer medium.
Yes. The formula will change when the object comes in the
denser medium.
Right. तो अभी मेरे पास दूसरा फॉर्मूला भी हो गया. देखो यहाँ पर क्या था बच्चा? My surface was क्या? ये देखो, ये surface को क्या बोलेंगे हम लोग? What will I say about the surface? I know that this surface is a कौन सा surface? कौन सा surface?
Mirror.
अरे मिरर नहीं है, कॉन्वेक्स सरफेस है.
Convex surface. हाँ मैम. Sorry.
नहीं. Okay. People do get surface. देखो अगर मेरा रिफ्लेक्ट होता तो वो मिरर होता बेटा. ये रिफ्रैक्टिंग सरफेस है. Let me explain to you once more. ये मेरा सरफेस है और यहाँ पर पूरा मेरा यहाँ पर एक डेंसर मीडियम रख दिया है. पूरा कहाँ तक? पूरा इंफिनिटी तक एक रिफ्रैक्टिव इंडेक्स mu2 का रखा है, यहाँ पर mu1 का रखा है ना? Here what is happening? Refraction is happening, not reflection. Reflection किस में होगा?
In the mirror.
इन द मिरर होगा, अगर इस सरफेस में भी होगा तो दैट इज टोटल इंटरनल रिफ्लेक्शन, दैट इज टोटली डिफरेंट केस. नाउ हियर
हाँ.
टोटल इंटरनल रिफ्लेक्शन इज नॉट हैपनिंग. इज दिस क्लियर टू ऑल ऑफ यू बेटा? All of you बोल रही
Yes.
हो, you are alone now. Okay, now what is happening is I have taken the case number 1. Now what will happen if I take a convex surface? Now is this image clear, or I should draw it, redraw it again on it?
It's fine, ma'am. It's clear.
क्लियर ना? देखो ये फिर
Yeah.
से मेरा कॉन्वेक्स सरफेस है, और इस
हाँ.
कॉन्वेक्स सरफेस में आई हैव गॉट द ऑब्जेक्ट वेरी क्लोज टू द पोल.
Okay.
In previous cases what happened?
It
Object was
was
far
away
from the
from.
pole and the image was formed in the denser medium, inside the denser medium. देखो यहाँ बढ़ रहा है.
Hmm.
अब
हाँ.
ये वाला केस में क्या डिफरेंस है? ये वाले केस में क्या डिफरेंस हो गया? मेरा
ये जो
ऑब्जेक्ट जो ना मेरा, इट वाज वेरी क्लोज टू द पोल, सो द रे वेंट हियर एंड हिट द surface at the point say M. How do I draw the normal बच्चा? I need to find out the center of curvature. Center of curvature से जहां आके इंसिडेंट रे ने यहाँ पर टक्कर मारा ना, वहां से एक पूरा रेडियस डालो. What is this? This is the
normal.
normal. Now what will happen to this normal here? This is the angle of incidence. See, this is the
Angle of incidence.
okay. Now what has happened to this angle of incidence, bacha? This angle of incidence is now entering what medium? It is
Denser medium.
entering a denser medium. It should bend towards the normal. So this is the
Yes.
normal. The dotted lines is the normal. This ray is
हाँ.
bending. You can see this is the angle of incidence, which is a large one as compared to that of the angle of refraction. But is it going and meeting the principal axis? No, it is going in this way. So image कहाँ बनेगा?
पीछे बनेगा.
पीछे बनेगा. That means you have to extend the ray back, and then you also extend this ray back, and the final image is formed here. And you can see the image is
Virtual.
the image is virtual. Is it clear?
हाँ, ma'am.
Okay, now did you understand the clear picture now? If you keep it slightly far from the pole of the mirror, you will get a real image. But if you keep it very close, then in that case, you will be getting a virtual image.
Virtual image.
Yeah. Okay, now again, I'm going to do the same thing now, the same kind of the diagram, but the situation is different, right? So diagram is different. Now the case is you have to draw the angle of, say, the incident ray. This is the ray number 1. I can see this is the pink one I've shown you here. This angle, the ray, incident ray is going to make an angle of alpha with the principal axis.
हाँ, ma'am.
Now this is the refracted ray. I'm going to show it to the green, and this green ray, you can see that if it is extended back, it is going and meeting the principal axis here, and you get an angle here, beta. Khatam back.
Yes.
Now यहाँ पर जो एंगल बना है ये बीटा है, और नॉर्मल ने जो इंसिडेंट रे के साथ में जो बना रहा है, that angle is called as the gamma.
Gamma.
Right? Okay, now again, next thing what you have to do is you have to draw a perpendicular from the point where it has hit to the line out here. You will call this a P dash, whatever you want. Now the distance between the pole and the mirror, that is called as U, and here this will be a negative value because it is in the same the direction of the distance. You have to measure it from the pole to the object. It is opposite to the direction of the incident ray, so it is negative. P is also negative.
P is also negative.
And what about R? R
is positive.
Okay. Now I am going to find out again the same the triangle which I am going to consider. Which triangle should I consider for the angle of refraction, and which one should I consider for the angle? So I'll just have to like I have to go and shade it. So I'm going to shade it in blue. So if I want to get the angle of incidence, which triangle should I consider? I want this.
MOP.
So I'll make this as blue. You can see this.
Yes, ma'am.
So what is it? Angle I क्या हो जाएगा?
Angle I will be beta, no?
Beta?
Yes, ma'am.
Only beta?
Angle I is equal to alpha also.
Tell me which triangle I'm going to consider.
For I, no, ma'am, small I, so
This angle.
that one, so it will be MOP dash.
Yeah, fine. That is fine. But which, it is equal to what? Exterior angle of which triangle? In triangle, which triangles का, किस triangle का वो exterior angle बन रहा है?
For triangle MIP dash.
MIP कैसे बनेगा बेटा उसका exterior?
अच्छा, हाँ, MOP dash के लिए बनेगा.
MOP dash नहीं नहीं. Exterior angle. Now see this triangle बच्चा. ये ट्रायंगल का देखो, ये एक्सटीरियर एंगल बन रहा है, नहीं
हाँ
बन रहा?
मैम।
है ना? थोड़ा ध्यान से देखो बेटा, एक्सटीरियर एंगल थ्योरम लगाना है ना अपन को, लगा,
हाँ
है ना? तो ये वाली
हाँ।
एंगल होगा इन ट्रायंगल क्या, एम ओ सी.
ओ सी।
You can see the triangle. I've shaded it a green. If it is visible or not, I don't know.
इट्स विजिबल मैम, इट्स विजिबल।
Okay, if not, I'll change the view now. Should I? 10 minutes में हो जाएगा, कुछ मिनट में अपने पास इसमें to say the view. View,
ओके मैम।
view, 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 view. Where is it gone? Page color. No color. अरे, page color, no color. No color. No color is not coming. Okay, fine, no issues.
ओके मैम, इट्स
It's visible ना? Green वाला दिख रहा है ना? So what is
यस।
the angle I beta? Angle I is equal to alpha plus gamma.
हाँ।
Now I want to find the angle R. Which triangle should I consider?
For angle R, it will be a triangle MIC.
M
IC.
IC. Okay. Now MIC and triangle this one. So what is the value of R? R is equal to?
Beta plus gamma.
Okay, fine. So I've got the value of I. I got the value of R. So what should I
Hmm.
write? Which law?
Snell's law.
Snell's law. What does it say? Mu
Mu1 sin I is equal to mu2 sin
R. Okay. So what should I write here? Mu1 I is equal to mu2 R. And then I said that mu1
mu1 alpha plus gamma,
alpha plus gamma. And that is equal to mu2.
mu2 beta plus gamma.
So mu1 into tan alpha plus tan
Alpha plus
gamma is equal to mu2 tan
tan beta
plus,
plus tan gamma.
right? Okay, so this is what mu1 tan alpha bolo bolo dekh ke bolo jaldi.
Tan alpha, it will be MP dash
I'll
by
write it.
OP
I'll
dash.
write it for MP. I'm skipping that step. Skip
Okay,
करूँ
ma'am.
क्या? करूँ क्या? हाँ, so मतलब ये P और P dash को मान लेते हैं, एक step लिखना पड़ेगा. The derivation we have to write. But here,
Yes,
just to make it fast, I'll write it as MP divided
MP
by
by
what?
OP.
MP by, नहीं, or don't write it as OP. Always read it as
U.
U. मतलब क्या हो जाएगा? It will be PO बेटा. Plus tan gamma के लिए क्या करोगे? It is,
Tan gamma, it will be MP by PC.
yeah. And what about mu2 tan beta?
Mu2, it will be
MP by,
MP by PI.
okay. And then plus,
Plus gamma के लिए M, sorry, gamma MP by PC.
okay, fine. So put the values here. Mu1 MP is to be taken as common. Then what you should do? 1 upon P.
1 by
PO क्या है?
1 by minus U.
PC क्या है?
1 by R.
Mu2.
Mu2 into MP will be 1 by PI is PI is minus U
Plus,
plus 1 by R.
okay. Now open this. You'll get
So
MP
it will be
यहाँ पर भी था, MP यहाँ भी था, कट गया. So you will get mu1 by minus U.
minus U plus
mu1
1 by
है
R.
यहाँ,
Mu1 by
that is equal to mu2 by
minus
minus
U
C plus.
plus mu2 by R.
Now what I can do here, I'll take this here. And I'll take this here. You will get
Yes.
what? 1 upon mu2 by V minus mu1 by U. That is
Is
equal
equal
to
to
mu2 minus mu1 divided by R. Now, is this the same result?
yes, ma'am, same result.
Same result. Why? Because the object
Is traveling from
was in,
rarer medium.
clear?
हाँ ma'am.
And
Clear.
if the object was, this is like, see, I have drawn again for which one? Now, again, I have drawn this object is in the rarer medium.
Rarer medium.
And here the surface is which surface? It is the,
Concave surface.
then also I'll get the same result.
Hmm.
But the diagram is very important. What is the formula? It is mu2 by V minus mu1 by U. That is equal to mu2
Mu2
minus
minus
mu1
mu1 by
by I. If the object is in the, if the object
rarer
is in the rarer medium, but if you have the object is in the denser
dense
medium, but if object is in the denser medium, formula will change, right? What will be the formula then? In that case, it will be mu1 by V minus mu2 by U. that is equal to mu2 minus mu1 divided by r. What is the change out here? पहले हम देख रहे थे mu1 के नीचे u था, इसके नीचे mu है,
के नीचे,
राइट? डिफरेंस समझ में आया?
हाँ मैम, समझ में आ गया.
ठीक है. So it has to be a different formula for both of the cases. Clear?
Yes.
Okay, but the formula will change. Now you have got the 6 cases. See, because in examination it is not necessary that the case which I taught you, the same case will come. It may be the case number 1, it may be the case number 2, it may be the case number, that is this is the third case, or this is the second case, right? Now this is the third case, or it may be this any of the 6 cases.
Okay.
So you did not have to do all the 6 cases. You should know only the diagram. See, the first case, what? The surface is convex. Object was in the rarer medium. Image कहीं भी बन सकता है, मतलब नहीं है. लेकिन हमारा ऑब्जेक्ट देखो, ये वाला केस और ये वाले केस में, दोनों में से इसमें क्या हो गया? ऑब्जेक्ट इज इन द
rarer medium,
है ना? And the image in the first case is in the denser medium, in the second case it is in the
rarer medium.
Doesn't matter. What is the important thing? कि ऑब्जेक्ट मेरा कहां पर है.
Okay.
Consider where is the
object.
We are not interested in considering where the image is. It should be where the object is. Is it clear? Now you have to draw all 6 diagrams, and if the diagram is correct, if the U, V and say R are properly marked, alpha, beta, gamma is properly marked, you will always get the correct derivation. Now within 1 minute my Zoom will end. So what we should do? Reconnect, right? Okay.
Yes.
So yeah, in this any doubt?
No ma'am, everything is clear.
Clear. So you have to go and do it. Now I'm going to teach you this lens makers formula. In school में भी ऐसे ही बताया है कि दूसरा बताया है?
ऐसे ही बताया.
ऐसे ही बताया है. So what exactly is the doubt you have got?
The derivation.
Derivation part, it is so simple. ठीक है, I'll teach you in 1 minute.